Okay, in this video, what I'm gonna do, I'm gonna go to population and write the function for natural selection, and I'm gonna because natural selection is at the right time. I'm just using the father by the random. Uh, doesn't care. I don't care about the fitness, but I want to care about the fitness. Bring the fitness. Who is having the better fitness? Who is having the better fitness is have a more chance to produce children, and natural selection. And I think based off the even love is about finding the better genetic is because of life is like that. And I'm gonna go for the natural selection and just um, avoid. And what we're gonna do here, I'm gonna create the list of the here I'm gonna have the list of the I have to create the mating pool. Mating pool is the one array of the DNA, and I'm gonna just, as you can see here, I have the list of the integer, but I'm gonna do one list more in list of the DNA, and I'm gonna say DNA is it gonna be list of the DNA, and I'm gonna call it is a mating pool, and what I'm gonna do is okay, that's because I'm running the program, change the program, so just terminate, and I just save the program. And in the natural selection, what I'm gonna do, I have to explain about why I'm doing this, because imagine, let's say I bring the paint, hopefully paint is here still now, and I'm gonna say what's for making who have a better fitness to have a more chance to be father and mother. Imagine I have a one basket, one bag, and I have a father and mothers and different DNA. And what I'm gonna do, I'm gonna just write the DNA. The bad DNA is, for example, imagine I just put the 3 bad DNA, and the green DNA, imagine, is a good DNA, and I just this is the put the lots of green DNA. When I put in the lots of better DNA, and in the same time I don't want to eliminate the bad DNA because they have to win part of our algorithm as well. When I'm doing this in bit 2D, I have a 2 DNA, but I'm put them 2 DNA. Some of them they are is the good better, and some of them is not. That is the copy of the DNA. When I have the copy of the DNA more, the probability of the green is much bigger than the bad DNA. That's why the mating pool is called. This one is called mating pool. It's going to be the list of the array. I'm going to just I'm related to the ratio of the fitness. I'm going to put more good DNA to my mating pool than the bad DNA. That's why in the same time I have a chance to choose the bad DNA, and in the same time I have a better DNA. I have a better DNA. The probability of the choosing the better DNA is much more than there's bad DNA. I hope you understand what I'm gonna do, and that's why I'm coming as the first every time I'm just mating mating where is the mating pool dot clear, because we're gonna every time just gonna write it, and I say for, I'm gonna say inter I is equal 0. I'm writing the code of the population. I'm writing the code of the population array. Population array. How to create that basket where mating pool is there, and length and I++, and I'm gonna say the randomly. I have to randomly choose 2. Randomly is the choose the item. is let's say for and I'm gonna say int R&D is equal and math, where I'm going to write math in the what I'm going to do here is I'm going to say random is actually is this is not random. First is like a percentage. I want to just look at my population, my item, my DNA. How much is the successful in the till now? How much is the fitness? I'm gonna is a kind of normalization. Is a I'm gonna say math. No, not math. It's not going to be random here, and I'm gonna say population, population array, population array, and I. And I'm gonna just say fitness max fitness is an integer and divided by the again the population max fitness. Okay, but because they are integer, I have to write double, and double is like a float, and because we're not divided to not losing, and is double as well, and because they are int, and I have to at the end I have to cast it to int to get a percentage. For example, if it's 78% is going to be 78, and I'm going to use that PRC as a number of the DNA good. Number of the DNA, I have to put this item in the mating pool. That's why I'm saying for how many of this DNA I have to write it to my pool, mating pool. I'm saying that's for int j is equal to 0 and j less than what? Let percentage. That is the number of the rate of the good. It's because in this way I normalize my my fitness to between 0 to 100, is because always the maximum fitness is we're gonna have the maximum we're gonna have pers and j plus plus. What I'm gonna do here, I'm gonna just say mating pool dot add. What is going to be the add is my population array is my population array I, and I'm gonna, for example, if something is a 73, I'm putting 73 of that in the mating pool. At the end of the day, end of the function, I'm gonna have the basket of the different. Let me just show you. I'm gonna have the basket. For example, this is the one of the DNA, and I just show you. I have this yellow one, copy of the 10 of them. At the end of the day, my mating pool is a probability picking the random from my mating pool is going to be the probability of that's what I'm saying. That's going to be have a better chance for the who is having the good gene. Here, as you see that I'm saying that instead of the here I'm choosing the randomly mother and father. Now I'm choosing the mother and father instead of my population array. I'm going to say is my mating pool. My mating pool is going to be much bigger than my population, and I just say okay, is going to be my mating pool because it's going to have the size, and if you don't have the length here, and it's going to be the same. Be choosing the random because the math random is just generate between 0 and 1. That's how we make it the father and mother, and we're gonna say instead of I'm gonna finish very quickly mating pool, changing this from population array mating pool. That's fine, and